Welcome to another lecture of modern physics. Students, in this lecture, I'm going to explain you photoelectric effect. Students, before we start photoelectric effect, I advise you to have a pen and a notebook because there are so many theoretical definitions which I'm going to dictate you, and you have to write simultaneously. First of all, what is photoelectric effect? You know, students, when electromagnetic radiations of suitable wavelength or frequency are incident on the metallic surface. See, this is a metallic surface, is incident on a metallic surface. Then what happens? Photoelectrons are emitted when the suitable wavelength is made incident on the metal surface. Then photoelectrons are emitted, right? And this phenomenon is called photoelectric effect. The traditional definition is when a light of suitable wavelength is made incident on the photosensitive metal, then photoelectrons are emitted. So this phenomenon is known as photoelectric effect. And what are emitted are known as photoelectrons. They are known as photoelectrons. What is photoelectric current? Photoelectric current, if the current passes through the circuit in the photoelectric effect, then the current is called photoelectric current. For example, if the current is passing through the circuit in the photoelectric effect, how come? Like we made the light incident here, then photoelectrons so emitted, they start moving towards this positively connected, this is called anode. Then what happens? Electrons are going like this, the current is flowing like this. So students, that is called what? Photoelectric current. Now you're clear with the three definitions. What is photoelectric effect, what are photoelectrons, and what is photoelectric current. Now I'm going to explain you work function. What is work function? The minimum energy required to eject the most loosely bound electron on the surface of the photosensitive material is called work function. Like when light of suitable wavelength is incident on the metal, then what happens? The photons and the surface at the free electrons at the surface, they interact, then they are knocked out from the surface, and that minimum amount of energy which is just required to knock out the electron from the surface of the metal is called what? Work function. Is called what? Work function. Hope it is all clear. I've told you what is photoelectric effect. Photoelectric effect is that effect in which the light of suitable wavelength is made incident on the surface of the metal. And photoelectric current, the current so generated due to the photoelectric effect is called photoelectric current. And then I have told you what is work function. It is the minimum amount of energy required to knock out the most loosely bound electron on the free surface of the metal, photosensitive metal. And how it functions, I have explained through this, right? Now, is it all clear? Now we move to the next. Now students, I'm going to explain you. Plate 1 is called emitter and plate 2 is called collector. Plate 1 is called emitter. Emitter is also known as cathode, and this is known as anode. Correct? Now I'm going to give you a definition that is called saturation current. What? Saturation current. Now you will put a question, sir, what is the meaning of saturation current? Right? You know, when all the photoelectrons by the cathode reach the anode, when all the photoelectrons by the cathode reach the anode, then the current flowing in the circuit, at that instant is called what? Saturated current. That is the maximum value of photoelectric current. Hope it is clear. When all the electrons emitted by the cathode are reaching the anode, then the maximum value of current is obtained, and that value of current is called what? Saturated current. Is it clear? Then next definition is stopping potential. Students, write down the definition of stopping potential. Stopping potential, the minimum magnitude of the negative potential of anode with respect to cathode, for which the current is zero, is called stopping potential. This is also known as cutoff voltage. The voltage is independent of intensity of incident light. I'll explain this. You know, electrons are negatively charged. When cathode is pushing the electrons are accelerated. The anode is positive, cathode is negative. Now we are decreasing the potential of anode. Means we are making the potential of anode negative. Are you getting? Electrons are negatively charged. Okay? They are moving towards anode. Correct? Anode is made negative slightly. Electrons is say this is anode. This is electron. It's coming, and it's not reaching here. It is also made negative. Neither it is repelled, but it's coming from cathode and reaching just here. This potential is called what? Stopping potential. This is the voltage that is known as what? Cutoff voltage. Correct. The next definition is retarding potential. What? Retarding potential. Retarding potential. What is it? Write down. The negative potential of anode with respect to cathode. The negative potential of anode with respect to cathode is known as what? Which is less than the stopping potential. Which is less than the stopping potential is called what? Retarding potential. Means electron is coming, photoelectron is coming, but speed is decreasing and it reaches here. With decreased speed, this potential is called what? Retarding potential. So I have cleared so many definitions to you. Hope it is all clear. And I'm going to explain in the second version called Hindi version also. Any doubt? It's okay. Thank you.